topic for today is chemistry in the atmosphere. I'll discuss about what is chemistry and the composition of the chemistry. So let's start. I'll discuss first a brief history about the Earth atmosphere. 5 billion years ago, that was known as the Earth forms as very hot ball of dust and particles that eventually forms enough gravity to stick together. At this point, it is too hot to have an atmosphere. And then for 4.5 billion, the Earth was cooled. The Earth was cooled from hot. It turns to cold to form a crust. And there are thousands of volcanoes on Earth's surface. These volcanoes spew out mostly oxygen, H2O, and a little methane and ammonia. So the Earth cooled down and starts to form surface, mostly magma and liquid rocks. So after discussing a brief history about the atmosphere, let us proceed to what is atmosphere. So atmosphere is the mixture of gases that surrounds the Earth. It is the envelope of gases that surrounds the planet. The atmosphere is made up of mixture of atoms and molecules. So another definition of atmosphere or another information, the Earth surrounded by a blanket of air which we call the atmosphere, which reaches 560 kilometers from the surface of the Earth. The next one is, parang ito yung parang advantage ng atmosphere sa atin. First, atmosphere absorbs the energy from the sun. Second, recycles water and other chemicals. The third one is protect us from high energy radiation and the frigid vacuum phase. And the last one is the atmosphere protects and supports life. So that is the advantage of the atmosphere to us as human. So now, let's proceed to the composition of the atmosphere. So I'll be showing a two figure which shows the atmosphere today and the atmosphere on the early, So, this is the early atmosphere. So this big part is containing carbon dioxide, and this shaded color green is the nitrogen. So the next figure is the atmosphere of the Earth today, which contains gas makes about 78% of Earth atmosphere. This is the nitrogen, the green shaded part, which contains 78%. And the yellow shaded part is the oxygen, which is the most abundant gas is oxygen, which makes up 21% of the Earth atmosphere. And the blue shaded line is the other gases. So apart from the level of nitrogen, there are two obvious differences between early atmosphere and the atmosphere today. As you can see, the nitrogen in the early atmosphere is the green line, which is different from the atmosphere today. It contains a lot in the Earth atmosphere.
Hi there, Mylene here from Group 2, and today we're gonna talk about one of the oldest form of trying to reliably predict the weather, more or less, and that is by measuring the amount of air pressure over a given location. And when we're talking about air pressure, we're talking about the amount of weight that is being exerted over a given location by the Earth atmosphere. You have to remember that the Earth atmosphere is about 300 miles thick, also pulled towards Earth's surface by gravity. This makes the atmosphere denser than Earth's surface. The entire mass of Earth's atmospheric gases is located with 30 km of the surface. The air is less dense at higher altitudes. This makes breathing more difficult. However, if you look weather forecasts, and you probably heard your local meteorologist referred to air pressure measurements as the barometric pressure. Because we use an instrument called barometer to take those measurements. In the United States, they measure air pressure in inches of mercury, while in other parts of the world, they use millibars. However, at sea level, the average air pressure is about 29.92 inches of mercury, and that works out to about 13.25 millibars. Since this is measuring air pressure, if we were to convert that over to a measurement of weight, that works out to about 14.7 psi, or what we call pounds per square inches. If you were to go higher in elevation, the air pressure is actually decreases, and that because you're decreasing the amount of air atmosphere that's above you. If you go lower elevation, the reverse is true. So if you go in lower in elevation, the atmosphere pressure actually increases because you're increasing the amount of the air atmosphere that's above your head. That's the reason why your ear pops when you're going down or up in an airplane, or when you climbing a mount or descending a mount. Earlier, that measuring air pressure is one of the oldest ways of trying to predict the weather. That's because when you get higher pressure, we generally get sunny weather. As we get lower in pressure, we generally get stormy weather. And if you had an aneroid barometer, you probably had a needle on the dial that you can adjust, and that needle allows you to mark the current barometric pressure. If you notice that the barometric pressure is getting lower from that needle that you can adjust, and that means stormy weather usually headed your way. If you notice that the barometric pressure is increasing from that needle that you can adjust, that means that nice weather usually headed your way. One last thing, when it comes to working or any kind of tropical system, your meteorologist reference the atmosphere pressure or the barometric pressure, the air pressure in the storm a lot. And that's because that is a very good indicator whether the storm is strengthening or weakening. The lower the pressure gets, the more powerful the storm can be. The higher the pressure gets, the weaker the storm usually is.
My name is Flonard Jr. and we tackle about the layers of the earth. Every layers of the earth is based on the temperature that they have. These layers are the troposphere, stratosphere, mesosphere, thermosphere, and a farther region above the Earth's surface is called exosphere. Ang layers of the atmosphere ay importante sa ating mundo dahil isa ito sa mga promoprotekta dito. Kagaya sa mga asteroid, pagbalance ng init ng araw, at iba pa. Mapunta na tayo sa pinakataas na layers ng ating mundo. Ito ay ang exosphere. Ang exosphere ay upper limit of our atmosphere na nasa taas ng thermosphere na merong 10,000 km extend above of the thermosphere na merong temperature na 2,000 degrees Celsius. Masasabi natin dito na ang exosphere, ito ay ang outer space natin na walang exact na lawak. Dumako naman tayo sa pagitan ng exosphere at ang mesosphere. Ito ay ang thermosphere. Ang thermosphere ay merong 600 km extend above of the mesosphere na merong temperature na 1,500 degrees Celsius. Ang purpose nito, dito lumulutang mga satellite at ang aurora na nag-absorb din ito ng solar radiation at nagre-reflect ng radio waves.
Okay, yung next is mesosphere. Mesosphere extend 80 kilometers high papunta sa thermosphere. And mesosphere has a cold temperature. At dito rin dumadaan yung mga shooting star. Nandun sila in mesosphere. Mesosphere, gases less dense. O meaning parang mababa na yung gravity or hindi ka na or para lumulutang ka na lang. Ganun siya. Okay, yung next naman is stratosphere. Stratosphere, dito yung mga moon and sun. At less dense. So meaning parang less water vapor. Parang hindi siya nag-evaporate yung tubig pataas kasi sabi nga less dense. And this layer has a high level of ozone layer. Yun. Mataas yung level ng kanyang ozone layer. At tawag din sa pinakataas ng stratosphere ay stratopause. Yun yung tawag din sa pinaka-upper boundary niya. So, ang next natin, yung pinaka-manipis na layer ng atmosphere. Kung saan tayo naririto ba? Ganun. Is yung troposphere. Troposphere is 20 kilometers high papuntang stratosphere. Parang doon dumadaan yung mga airplane, yung mga air balloon, yung mga nakikita nyo, tsaka yung mga volcan, yung pinaka-top tuktok nila, yung troposphere. At tsaka yung tawag doon sa yung between of the troposphere and stratosphere is tropopause. Yun yung tawag doon sa dalawang yun. Yung sa pinaka-between nilang dalawa is stratopause. After nung troposphere is kung nasaan na tayo, kung saan na tayo nakatayo. Ganun siya. Yung parang pagkakasunod-sunod nila is first is troposphere, and then after na troposphere, stratosphere, after ng stratosphere, pataas na layer, mesosphere, at thermosphere. Yung pinakataas or yung pinakataas ng layer ng atmosphere is the exosphere. Yung parang less gravity na wala na talaga, para lumulutang ka na lang. Ganun siya. Thank you po. My name is Ajay and David.
Layers of the atmosphere based on composition of gases. Based on chemical composition, the atmosphere is divided into two broad layers, the homosphere and the heterosphere. The homosphere extends up the height of 56 miles, 90 km, and is characterized by uniformity in chemical composition. It consists of three thermal layers, namely the troposphere, the stratosphere, and the mesosphere. Each sublayer is separated from the adjoining layer by a shallow transitional zone. The heterosphere has heterogeneous chemical composition with layer structure of nitrogen, oxygen, helium, and hydrogen, respectively. Generally, the atmosphere consists of 5 layers, namely the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. The thickness of these layers is slightly different around the globe, and also varies with respect to the temperature and season. These 5 layers of the atmosphere act as safety blankets, regulating the Earth's temperature and maintaining life forms in it. The 5 layers of the atmosphere include the troposphere, where we live, the stratosphere, which contains the ozone layer, the mesosphere, where meteors burn, the thermosphere, where satellites orbit Earth. The exosphere is also 500 kilometers above Earth and does not have a specific outer limit. The exosphere and the ionosphere. Communication on Earth depends on satellites. Satellites transmit information used for television shows, radio, broadcast data, and photos used in weather reports, and long-distance telephone calls. Ozone layer absorb the sun's high energy ultraviolet radiation and protect the Earth.
The atmosphere layer is corresponding with how the atmosphere temperature changes with altitude. By understanding the way temperature changes with altitude, we can learn a lot about how atmosphere works. While weather takes place in the lower atmosphere, interesting things such as the beautiful aurora happen higher in the atmosphere. Why does warm air rise? Gas molecules are able to move freely, and if they are contained as they are in the atmosphere, they can take up more or less space. When gas molecules are cool, they are sluggish and not take up as much space with the same number of molecules in less space. Both air density and air pressure are higher. When gas molecules are warm, they move vigorously and take up more space. At air density and air pressure are lower. The atmosphere is divided into layers based on how the temperature in that layer changes with altitude. The layer's temperature gradient, the temperature gradient of each layer is different. In some layers, temperature increase with altitude, and in others it decreases. The temperature gradient in each layer is determined by the heat sources of layer. Most of the important processes of the atmosphere take place in the lowest two layers. The temperature of the troposphere is highest near the surface of the Earth, decrease with altitude. On average, the temperature gradient of troposphere is 6.5 degrees Celsius per 1,000 meter and 3.6 degrees feet per 1,000 feet of altitude. What is source of heat troposphere? Earth surface is major source of heat, the troposphere. Although nearly all of the heat comes from the sun, rock, soil, and water on Earth absorb the sunlight and radiate it back into the atmosphere as heat. The temperature is also higher near the surface because of greater density of gases. The higher gravity causes the temperature to rise. Notice that in the troposphere, warmer air is beneath cooler air. What do you think the consequence of this? This condition is unstable. The warm air near the surface rises and cool air higher, or in winter when the ground is cold, the cold ground cools the air sits above, making this low layer of air denser than the air above it. Near the poles where the cold center cools the air above it, when the denser air moves inland, it slides beneath warmer air over the land. Since temperature inversion are stable, they often trap pollutants and produce unhealthy air conditions in cities. At the top of the troposphere is thin layer in which temperature does not change with height. This means that the cooler, denser air of the troposphere is trapped beneath the warmer, less dense air of the stratosphere. Air from the troposphere and the stratosphere rarely meet.
What is energy? Energy is the ability to do work. Energy is defined as the capacity of a physical system to perform work. However, it's important to keep in mind, just because energy exists does not mean it's necessarily available to do work. There are 10 forms of energy: mechanical energy, thermal energy, nuclear energy, chemical energy, electromagnetic energy, sonic energy, gravitational energy, kinetic energy, potential, and ionizational energy. Describe solar energy. Solar energy is simply the light and heat that come from the sun. Solar energy can be harnessed directly or indirectly through human use. Movement of energy. Energy can move from one place to another. It can travel through space or matter.
We're going to talk about how energy moves through the atmosphere. But first, we have to know what is energy. So, what is energy? Energy travels through space or material. When you pick up the handle of a metal pot, even though the handle is not sitting directly on the hot stove, invisible energy wave can travel through air, glass, and even the vacuum of outer space. These waves have electrical and magnetic properties, so they are called electromagnetic waves. Again, they are called electromagnetic waves.
Conduction. It is the flow of heat from warm object to cold object when placed in direct contact. Heat is transferred from molecule to molecule by contact. Ito yung pag-transfer o paglipat ng init sa malamig na bagay. Example, kapag nilagay mo ang bakal sa apoy, iinit ito dahil magtra-transfer ang init.
Convection. Convection is the transfer of heat by a current. Convections happen in a liquid or a gas. Air near the ground is warmed by heat radiating from Earth's surface.
The transfer of energy from one object to another through electromagnetic waves is known as radiation. Again, the energy from one object to another is called electromagnetic waves is known as radiation. We feel that same energy around us. For example, when we stand near a fire.
What is greenhouse effect? Earth is a comfortable place for living things. It's just the right temperature for plants and animals, including humans, to thrive. Why is Earth so special? Well, one reason is the greenhouse effect. A greenhouse is a building with glass walls and glass roof. The clear glass allows sunlight to shine into the greenhouse, while also trapping the sun heat inside. This is how a greenhouse keeps plants warm, even at night and in the winter. The greenhouse effect keeps Earth warm in pretty much the same way. Earth isn't surrounded by glass, but it is surrounded by a jacket of gases called the atmosphere. In the daytime, the sun shines through the atmosphere, warming Earth's surface. After the sun goes down, Earth's surface cools. This releases heat back into the air, but some of that heat is trapped by the gases in the atmosphere. These heat-trapping gases are called greenhouse gases. Carbon dioxide, water vapor, and methane are also examples of greenhouse gases. Earth needs a balance of greenhouse gases to maintain just the temperature for living things. But some human activities are changing Earth's natural greenhouse effect. For example, burning fossil fuels like coal and oil releases more carbon dioxide into our atmosphere. These extra greenhouse gases can cause the atmosphere to trap more and more heat, leading to a warmer Earth. NASA satellites are constantly measuring the gases in our atmosphere from space. They have observed increases in the amount of carbon dioxide and other greenhouse gases. This information will help us better understand the impact that greenhouse gases have on our climate.
Cutting trees, eating, burning fuel, all of these human activities add extra greenhouse gases to the atmosphere. As the level of these gases rises, so does the temperature of the Earth. The rise of Earth's average temperature caused by human activity is called global warming. If the atmosphere causes too much greenhouse effect, Earth just gets warmer and warmer. Too much of carbon dioxide and other greenhouse gases in the air are making the greenhouse effect stronger day by day and causing global warming. So let's see some of the ways to reduce these harmful greenhouse gases. We should always reduce, reuse, recycle. By recycling half of our household waste, we can save about 2,500 pounds of carbon dioxide annually. We should buy energy-efficient products that use far less energy than standard products. Plant a tree because they absorb carbon dioxide and give off oxygen. Should use less heat and air conditioning. Always drive less and drive smart to avoid pollution.
Good day, everyone. Today, let's talk about the global warming. Global warming is the rising average temperature of Earth, atmosphere, and ocean. It is caused by increasing concentration of greenhouses. So, sa madaling sabi, ito yung rising average temperature ng Earth, atmosphere, and ocean. Ito yung mag-i-increase naman yung concentration ng greenhouse gases. So, maraming epekto ang global warming. So, let's talk about the greenhouse gases. Ito naman yung water vapor, methane, ozone, nitrous oxide, and chlorofluorocarbons. So now, let's talk about the effects of global warming. Ito yung mga epekto ng ating global warming. Ito yung ice melting, rise in sea levels, wildlife effects, and human health, and lastly, increase in hurricanes.
Yan.
So now, let's talk about the ozone depletion. Ozone depletion is a ozone layer. Ito yung protects the Earth from the ultraviolet rays sent down from the sun, by the sun rather.
If the ozone layer is depleted by human action, are disastrous. Ozone is relation of oxygen and is made up of oxygen atom. Yun yung may tatlong oxygen atom. So now let's talk about the reaction. Ozone cells can be protolyzed with weak ultraviolet lights and if even with light from the range of wavelengths which can be seen by the human eye. So now let's talk about the natural cause. Volcanoes and ozone release large amount of chlorine.
Atmospheric problem. Acid rain. Acid rain is a mixture of sulfuric and nitric acid. Wet deposition. Rain, snow, hail, and fog. Dry deposition. Gases and particles. Environmental effects. Water and marine life. Extinction of fishes in lakes. Flora. Damage of plants, forests, crops, tissues, and dead whole tree. Soil. Improper growth of plants. Human health. Respiratory problem. Smog. Smog is the combination of smoke and fog. Types of smog are the reducing smog and the oxidizing smog, or photochemical smog. Conditions required for formation of smog are the number 1, sufficient nitrogen, oxygen, hydrocarbons, violet organic compounds. Number 2 are the sunlight. Number 3 are the movements of the air mass. This is the sources of smog. Man-made sources, vehicle exhaust, industrial emissions, biomass burning, and peg benzene. Natural sources, vegetation, trees, rainforest, and isoprene.